Good day, learners. Today we are going to study about solutions and factors of higher degree polynomials. Our example here is a quartic equation. If we don't have the zero here, it is only an algebraic expression, and we are just going to simplify or factor the expression. But if we have the zero there, it is an equation already, then we have to find the values of our x. Okay, so we have an equation here because this one is equal to 0. So let's have the trial factors for this. We need this one, the last constant, and the numerical coefficient of x to the fourth. Let us say this one is our letter A and this one is our letter B. So what is our trial factors? So for trial factors, I'm going to write here trial factors. We have to divide this. We get all the factors of B divided by all factors of A. So we have here. So here, for the B, we have 12. And then for the A, it's only 1. Get the factors of the constant 12. So the constant 12, we have our factors here. So we have 12, 1 times 12, 2 times 6, and 3 times 4. So if you are going to arrange it, we have 1 times 2 times 3 times 4 times 6 and 12. We divide this by the factors of A, which is only 1. So we have here the factors, the trial factors. We have plus 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 4, negative 4, positive 6, negative 6, and positive 12, negative 12. So there are so many trial factors. Okay, we start with 1. Start with the positive 1. Okay, to start with that one, we equate 1 here. If we are going to have x is equal to 1, so we will equate that 1 here to the old x here, and if that is equal to 0, then 1 is one of our factors. So let us substitute x is equal to 1 here. So we have 1 to the fourth plus 2, and then 1 cube plus 1 squared plus 8 times 1 minus 12 must be 0. So we have here is 1 plus 2 plus 1 plus 8 minus 12 is equal to 0. So 1, 3, 4, 12. So the positive is 12 minus 12 is equal to 0. So 0 is equal to 0. Therefore, one of the solutions of this one equation is x is equal to 1. So this one is really x minus 1. That is one of the factors. Why did I change 1 to negative? We will use now the synthetic division. That's why I changed that one to positive 1. I'm going to use the positive 1. So in synthetic division, instead of subtraction, in which I am going to change the signs of the subtrahend, I will not change anymore it because I have changed already the divisor of our synthetic division. So we are going to divide this expression here by x minus 1. And to make it easy, we will use synthetic division. So you must know synthetic division, or else you resort to the conventional method of dividing polynomials. So we have negative 1, so I am going to put here is our synthetic division. X is equal to 1, so this one is 1, but actually this one is negative 1. That one is, I changed that one into positive here. Then I will list the numerical coefficients of all the x here until 12. Now, take note if there is a missing term. If there is a missing term, you put 0 for that. It is the placeholder. Don't leave it. So let us have x to the fourth, x cubed, x squared, x, and the constant. So it is complete. So there is no 0. So we have the first one is positive 1. So I'm just going to write the 1 here. Okay. And then 3 is positive 2. So we have positive 2 here. X squared is positive 1. So I'm just going to write 1 here. And the x is positive 8. So simply 8 here. And the negative 12. So we have a negative 12 here. So these are the numerical coefficients of our x, and then the last one is the constant. Then after that one, we have this one here. And then first numerical coefficient, we bring it down. So 1 is here. Then we multiply this one by 1 here, our 1 there. So 1 times 1 is 1, put here your answer, and then you add 2 plus 1 is 3, then multiply again, 1 times 3 is 3, and then add 1 plus 3 is 4, and then 1 times 4 is 4, and add 8 plus 4 is 12, 1 times 12 is positive 12, and if you are going to add that one, our answer will be 0. It means that it is exact and we don't have any remainder. If this one is 0, then this one is one of the factors of this expression. So we have x minus 1 because this one is 0. If this is not 0 and we have a remainder here, you try negative 1 or x plus 1. If there is still a remainder there, and then next one is positive 2. Before the synthetic division, test first. After the positive 1, negative 1, if that one is not 0, take the 2 positive, put here 2 for 2, all 2's here. If that is equal to 0, then use the synthetic division. So that is the first one. So now, what will be our answer here? So we have x minus 1, okay, x is equal to 1, that is the root. And then x minus 1 is the factor, okay. And then this one, how do we write this one? This one is x to the fourth. The second one, this one is x cubed, because this one is x. So we have 1x cubed, okay, plus the second one is x squared, so we have 3x squared, and then plus this one is 4x, and then the last one is plus 12. Next is we are going to factor again this one. We will test again. Anyway, the last one is 12, and then this one is positive. Still, we have this factors here, 1, 2, 3, 4, 6, 12. And we are going to do the same procedure again to find the factors. X is equal to, and then we do the synthetic division again. Okay, we have already the first factor here, plus x minus 1, and we have the cubic expression here. This one is equal to 0 plus. Now, let us have this expression here, the cubic expression here, x cubed 12. Now, this one is 12, this is 1. Now, our trial factors are the same, 1, 2, 3, 4, 6, and 12. So, let us have x is equal to negative 3. Let's have this one, negative 3 cube plus 3 times negative 3 squared plus 4 times negative 3 plus 12, and if that one is equal to 0. So, negative to the exponent is negative. So, we have negative 3 times 3, 9 times 3 is 27. And then this one, negative times negative is positive, times positive is positive here. 3 times 3 is 9, times 3 is 27 here. Okay, negative times positive is negative 12 here. And then we have the plus 12, there is equal to 0. Then we add this one, 0, this, negative 12, and positive 12 is 0. So, it's okay. So, our x equals negative 3 is one of the factors. And we can write that one as x plus 3. Okay. So, we have x minus 1 times x plus 3, but what is the quadratic expressions now? So, let's have our synthetic division again. We have negative 3, so we put it like this. Okay, so we have x negative 3, so we have negative 3, and let us put here all the numerical coefficients of our cubic expression. X cubed is 1, positive. X squared is 3. X is 4. And the constant is 12. So there is no missing term. 3, 2, 1. You always check. If there is a missing term, for example, there is no x squared, you put 0 and then continue. Don't leave that one without 0. So after that, we have this one. This one is negative 3. So bring down 1. Negative 3 times this one is negative 3. And so we have 0. Multiply is 0. 4 plus 0 is 4. Negative 3 times 4 is negative 12. And 12 minus 12 is 0. This remainder is 0. Therefore, x is equal to negative 3 is our root, one of the roots. And we have x plus 3 there as our factors. So we can write again. This one, we equal this one. So we have x minus 1. And then the second one is x plus 3. So, what is this one now? This one is x squared. Because we have this one is the cube. Then the next one will be x squared. So, this one is 1 x squared, or simply x squared. And then 0 means 0x is 0. And then this one is plus 4. Is equal to 0 now. So our quartic equation now is reduced to this one. Can we still factor x squared plus 4? No. We don't have any factors if this one is plus. If this one is minus, yes. But this one is positive, so we cannot factor anymore, and we will not do anymore that one, or trial and error, or synthetic division, because we don't have factors for positive binomial, square of binomial. Okay? If our problem is quartic expression only, then we are just going to factor it. And our factor of this quartic expression is this one. But if we have the 0 there, then after this, we need to solve for the values of x. And here, we have 2 real roots and 2 imaginary roots. This one is imaginary roots. So, by zero factor property, we equate each of them to 0. So, for x minus 1, we have x minus 1 is equal to 0. Then x is equal to positive 1. The second one is this one. X plus 3 is equal to 0. Transpose, and x is equal to negative 3. So this 2, 1 and negative 3, they are the real roots. What about this one? So for x squared plus 4 is equal to 0. Transpose. So x squared is equal to negative 4. Then we take the square root here, square root there. So we have x is equal to plus and minus the square root of negative 4. But we don't have the square root of a negative number. So this one can be factored as square root of 4 positive times square root of negative 1, like this, factors. Factor negative 4, we have positive 4 times negative 1 is negative 4. And in imaginary number, this square root of negative 1 is what we call the I. Okay, square root of negative 1 is equal to I. Therefore, here, when we take the square root, x is positive, let's have the positive first. The square root of 4 is 2. And square root of negative 1 is I. So, first one is that one. And the second one is we have a negative here. We take the square root of 4 again, which is 2. And then square root of negative 1 is I. So we have 4 roots of our quartic equation. We have 1, negative 3, 2i, and negative 2i. So we have 2 real roots, and this one is the imaginary numbers.